Have you ever wondered what would happen if you could somehow step outside of everything? Not just outside your house, not just outside Earth, but outside of literally everything we can see, touch, or even imagine. Tonight, we're going to embark on a journey so mind-bending that by the end, you'll never look at the night sky the same way again. We're talking about the observable universe. And before you think this is just another space video with pretty pictures of galaxies, let me tell you something that's going to completely shatter your perception of reality. Everything you've ever seen with your own eyes, every star that's guided human navigation for thousands of years, every constellation that's inspired countless stories and dreams represents less than 1/10,000,000th of what actually exists out there. Let that sink in for a moment. Your entire visual experience of the cosmos, accumulated over a lifetime of looking up at the night sky, is so infinitesimally small compared to reality that it's essentially mathematically meaningless. And here's the kicker. Even this incomprehensibly vast observable universe might itself be just a tiny bubble in something even more enormous. If you're ready to have your mind completely blown and discover just how small and how significant you really are in this cosmic theater, then stick around. Because what we're about to explore will challenge everything you think you know about size, distance, and your place in existence itself. Now, when astronomers talk about the observable universe, they're not talking about everything that exists. This is crucial to understand right from the start. They're talking about everything we could possibly see, even with perfect instruments and unlimited time. The distinction matters because it reveals one of the most profound limitations built into reality itself. Picture this. The observable universe has a radius of approximately 46.5 billion light-years in every direction from Earth. That creates a sphere roughly 93 billion light-years across. But here's where it gets absolutely wild. The universe is only about 13.8 billion years old. So how can we see things that are 46 billion light-years away? Shouldn't the edge be only 13.8 billion light-years away? This is where space itself becomes stranger than any science fiction movie. Space is expanding, not just the things in space moving apart, but the actual fabric of space-time is stretching. While light from distant galaxies has been traveling toward us for billions of years, those galaxies have been carried farther and farther away by this expansion. It's like watching someone run toward you on a treadmill that's moving backward faster than they can run forward. This creates what scientists call the particle horizon, the boundary of our observable universe. Beyond this horizon lies the unobservable universe, regions that exist but remain forever hidden from our view. No telescope will ever peer beyond this boundary. No signal will ever cross it. It's not a limitation of technology or human cleverness. It's written into the fundamental laws that govern everything. Let's start building our cosmic perspective step by step. Because understanding the true scale of the observable universe requires us to first grasp just how empty and vast space is, even in our own neighborhood. Imagine Earth as a marble sitting on a football field. On this scale, the moon would be a peppercorn about 7.5 yards away. Already, we're dealing with distances that challenge normal thinking, but we've barely started. The sun would be a beach ball, sitting about 2.5 miles away from our marble Earth. And the nearest star beyond the sun? Another beach ball located roughly 13,000 miles away. This is just our immediate stellar neighborhood, and we're already working with distances that break human comprehension. Our entire solar system, including Neptune's distant orbit and the scattered objects beyond, would fit within a circle about 10 miles across on our football field scale. But our galaxy contains roughly 400 billion stars, each separated by these mind-numbing distances. If our solar system is 10 miles across, then the Milky Way would span the entire continental United States. And this is just one galaxy among countless others scattered throughout space. The Milky Way belongs to what's called the Local Group, a collection that includes our neighbor Andromeda, a few dozen smaller galaxies, and various dwarf companions. This entire local group spans about 10 million light-years across. But even this collection is just a tiny cluster in something much larger. We're part of the Virgo supercluster, a vast collection of galaxy groups and clusters spanning roughly 110 million light-years across, containing thousands of galaxies. When you look up at the night sky, every single star you see belongs to our one galaxy. But our galaxy is just one of thousands in this local supercluster, and we're still not even close to grasping the full scale. The Virgo supercluster is itself part of an even larger structure called the Laniakea supercluster, which contains roughly 100,000 galaxies spread across 520 million light-years. The name comes from Hawaiian words meaning immeasurable heaven, a fitting description for something so vast that light takes over 500 million years to cross it. Laniakea is just one of millions of similar superclusters scattered throughout the observable universe, like islands in an infinite ocean. Between these superclusters lie vast regions of nearly empty space called cosmic voids. These voids are so large that entire superclusters could fit inside them with room to spare. Some voids stretch over 1 billion light-years across, containing almost nothing but the occasional lonely galaxy drifting through cosmic darkness. This creates what cosmologists call the cosmic web, a stunning large-scale structure where matter is arranged in filaments and sheets separated by enormous voids. If you could somehow step outside the observable universe and look at it from a distance, it would resemble a vast three-dimensional spiderweb, with bright filaments of galaxies separated by dark, empty spaces. Here's what makes this truly extraordinary. The cosmic web isn't random. Its structure was determined by tiny quantum fluctuations that existed when the universe was smaller than an atom. These microscopic variations in density grew over billions of years, shaped by gravity and the expansion of space itself, until they became the vast architecture we observe today. Every galaxy cluster, every void, every filament in the cosmic web can trace its origins back to quantum uncertainties that existed in the first fraction of a second after the Big Bang. The universe has grown from quantum foam to cosmic web, from the smallest possible scales to the largest structures we can observe. But there's something even more remarkable about this cosmic web that speaks to the fundamental nature of reality itself. The visible matter that makes up galaxies and stars accounts for less than 5% of everything in the observable universe. The rest is composed of mysterious substances we call dark matter and dark energy. Dark matter makes up about 27% of the observable universe. It doesn't emit, absorb, or reflect light, but its gravity shapes the cosmic web, providing the scaffolding around which visible matter clusters. Without dark matter, galaxies couldn't have formed, stars couldn't have ignited, and the cosmic web itself couldn't exist. Dark energy comprises the remaining 68% of everything, and it's even more mysterious. This invisible force is driving the accelerating expansion of space itself, pushing galaxies apart and stretching the cosmic web ever larger. Dark energy is why distant galaxies are racing away from us faster and faster, and why the observable universe has a finite size despite ongoing expansion. This means the vast majority of the observable universe consists of things we cannot see, touch, or directly detect. We're like explorers mapping an invisible continent, inferring the presence of mountains and valleys only by watching how rivers flow around them. The cosmic web we observe is merely the visible tip of a much larger hidden architecture that shapes everything around us. Recent measurements suggest that the observable universe contains at least 2 trillion galaxies, each containing hundreds of billions of stars. That's more stars than there are grains of sand on every beach on Earth, multiplied by every beach that has ever existed throughout our planet's history. Let me put this in perspective. If you counted 1 star every second without stopping, it would take you longer than the current age of the universe to count all the stars in just one large galaxy. To count all the stars in the observable universe at this rate would require more time than has elapsed since the Big Bang, multiplied by trillions upon trillions. Yet despite containing this incomprehensible number of stars and galaxies, the observable universe remains mostly empty space. If we distributed all the matter evenly throughout its volume, we would end up with roughly 6 protons per cubic meter. That's emptier than the best vacuum we can create in laboratories on Earth. This emptiness isn't a flaw in cosmic design. It's a fundamental feature that makes complexity possible. Without vast spaces between stars, planetary orbits would be unstable. Without enormous distances between galaxies, gravitational interactions would prevent the stable structures necessary for life. The universe's emptiness is what allows islands of matter to exist as oases of complexity in an ocean of space. As we push our observations to greater distances, we're not just looking farther into space, we're looking backward through time itself. Light travels at a finite speed, roughly 300 million meters per second, which means distant objects appear to us as they were when their light began its journey to Earth. When we observe a galaxy 1 billion light years away, we're seeing it as it existed 1 billion years ago. The light carrying that image has been traveling through space for 1 billion years, crossing vast distances while the universe itself expanded around it. By the time that ancient light reaches our telescopes, the galaxy that emitted it may have evolved, changed, or even been destroyed by cosmic forces we cannot yet observe. This creates a remarkable consequence. As we peer deeper into space, we're witnessing the universe's history unfolding before us. The most distant galaxies we can observe appear young, chaotic, and fundamentally different from the mature spiral and elliptical galaxies we see nearby. We're watching cosmic evolution in reverse, seeing the universe grow younger and more primitive as we look farther away. The most distant objects we can currently observe are galaxies that formed when the universe was less than 1 billion years old. These ancient systems appear as small, irregular collections of stars, frantically forming new suns at rates hundreds of times faster than galaxies today. They give us glimpses of the cosmic dawn, when the first stellar nurseries were igniting throughout the expanding universe. But even these incredibly distant galaxies aren't the farthest things we can observe. The most distant light we can detect comes from something called the cosmic microwave background, radiation left over from when the universe first became transparent, roughly 380,000 years after the Big Bang. This ancient light fills the entire sky with a faint glow that's invisible to our eyes, but detectable by sensitive radio telescopes. It represents the afterglow of creation itself, the moment when the universe cooled enough for the first atoms to form and light to travel freely through space for the first time. Picture this. Before this moment, the universe was like a thick fog. Photons couldn't travel very far without bumping into free electrons, creating a cosmic soup that was completely opaque to light. But when temperatures dropped enough for electrons to bind with protons and form neutral hydrogen atoms, this cosmic fog suddenly lifted. The universe became transparent, and light that had been trapped was finally free to journey across space. The cosmic microwave background marks the edge of our observable universe, not because nothing exists beyond it, but because we cannot see anything that happened before the universe became transparent. It's like trying to peer through fog so thick that no light can penetrate. This creates one of the most profound realizations about the observable universe. We live at the center of our observable sphere, not because we occupy a special place in the cosmos, but because we can only see objects from which light has had time to reach us. Every observer in the universe sits at the center of their own observable sphere, each with a slightly different view of cosmic history. An observer in a galaxy 10 billion light-years away would see their own observable universe overlapping with ours, but extending in directions we can never explore. They might observe galaxies that remain forever hidden from our view, while some of the galaxies we can see lie beyond their cosmic horizon. Think about what this means. Right now, there are regions of space containing countless galaxies, stellar nurseries birthing new suns, and perhaps even civilizations asking the same questions we're asking tonight. But they exist in a realm so distant that their light will never reach us, no matter how long we wait or how advanced our technology becomes. The expansion of space itself ensures that our observable universe is constantly changing, but in ways that might surprise you. Every second, light from more distant regions crosses our cosmic horizon and becomes observable for the first time. We are constantly receiving new information from the early universe, watching the cosmic story unfold as ancient light finally completes its billion-year journey to our telescopes. But here's the paradox that will mess with your head. The accelerating expansion driven by dark energy means that many galaxies we can currently observe are moving away from us so rapidly that we will eventually lose sight of them. Their light will become so stretched by cosmic expansion that it fades beyond detection. Future astronomers will inhabit a lonelier universe with fewer visible galaxies and less evidence of cosmic history. In the far future, if current theories are correct, the observable universe will contain only our local group of galaxies. The rest of the cosmic web will have expanded beyond our horizon, leaving future civilizations with no way to discover the Big Bang, cosmic expansion, or the rich tapestry of cosmic evolution that we are privileged to observe today. This makes our current era special in cosmic history. We live at a unique moment when the universe is old enough for complex structures to have formed, but young enough that we can still observe evidence of cosmic origins. We are cosmic archaeologists working within a limited time frame, racing to understand our origins before the expanding universe erases the evidence. Every observation we make, every discovery we achieve, adds another piece to a cosmic puzzle that becomes more difficult to solve with each passing billion years. The observable universe represents not just a spatial boundary, but a temporal one as well. It defines not only how far we can see, but how much cosmic history remains accessible to scientific investigation. Now let's talk about something that will completely reshape how you think about your place in all of this. Consider this remarkable fact. Every atom in your body was forged in the nuclear furnaces of ancient stars that lived and died billions of years before our solar system even existed. The calcium in your bones, the iron in your blood, the oxygen you're breathing right now, all of these elements were created in stellar cores and scattered across the cosmos by supernovae that lit up galaxies when the universe was young. You are not separate from the observable universe. You are made of it. You are the cosmos becoming aware of itself, a temporary arrangement of stellar debris that has somehow achieved the extraordinary feat of consciousness. Through your eyes, the universe observes its own immensity. Through your mind, it contemplates its own origins and destiny. This connection runs deeper than mere poetic metaphor. The laws of physics that govern the behavior of galaxies billions of light years away are the same laws that govern the electrical impulses in your brain as you process these words. The gravitational forces that hold galaxy clusters together operate on identical principles to those that keep your feet planted on the ground. The electromagnetic radiation that carries information across cosmic distances is the same force that allows your neurons to communicate with each other. You are literally woven into the fabric of the observable universe through every fundamental interaction that makes your existence possible. But here's where the scale becomes truly mind-altering. If we could somehow shrink the entire observable universe down to the size of Earth, our own galaxy would be smaller than a single cell in your body. Our solar system would be invisible to the most powerful microscopes. Earth itself would be so inconceivably tiny that it would exist on scales smaller than we have words to describe. Yet on this infinitesimal speck, in a universe so vast that our entire galaxy is essentially a point, complexity has reached levels that boggle the mind. Life has emerged from lifeless matter. Consciousness has arisen from unconscious atoms. Intelligence has developed to the point where it can contemplate its own cosmic context and ask questions about the nature of existence itself. This creates one of the most beautiful paradoxes in all of cosmology. We are simultaneously insignificant and extraordinary. Insignificant because we occupy such an infinitesimally small portion of space and time. Extraordinary because, despite our cosmic smallness, we have managed to map the observable universe, understand its history, and predict its future. The observable universe reveals itself to us through light, that fundamental messenger that connects every corner of cosmic space. But light does more than just carry information. It defines the very structure of space-time itself, creating the boundaries of what we can observe and establishing the cosmic horizons that limit our knowledge. Einstein showed us that space and time are woven together into a single fabric, and the speed of light represents the maximum rate at which information can travel through this cosmic tapestry. This speed limit isn't just a property of light itself, it's a fundamental feature of reality that governs how cause and effect propagate through the universe. Every photon that reaches your eye from a distant star has been traveling at exactly this cosmic speed limit for years, decades, centuries, or even billions of years. These ancient messengers carry with them the history of their journey, encoded in wavelengths that tell us about the temperature, composition, and motion of objects scattered throughout the observable universe. When astronomers analyze light from distant galaxies, they're not just seeing pretty pictures, they're decoding messages that have traveled across unimaginable distances. carrying information about stellar births and deaths, the formation of heavy elements, the merger of galaxies, and the evolution of cosmic structure itself. But the expansion of space adds another layer of complexity to these cosmic messages. As light travels through expanding space, its wavelengths are stretched, shifting toward the red end of the spectrum. This redshift serves as a cosmic tape measure, allowing us to determine not just how far away objects are, but how fast they're receding from us due to cosmic expansion. The most distant galaxies we can observe have redshifts so extreme that their ultraviolet light has been stretched all the way into the infrared portion of the spectrum. What began as high-energy radiation from hot young stars reaches us as low-energy infrared light that reveals these galaxies as they appeared in the cosmic dawn. This stretching of light creates a natural timeline written across the sky. Nearby galaxies appear as they were relatively recently, showing us mature stellar populations and well-defined structures. More distant galaxies appear progressively younger, more chaotic, and more actively star-forming. The most distant galaxies of all appear as irregular collections of bright hot stars, furiously converting primordial gas into the first heavy elements. As we push our observations to ever greater distances, we're essentially watching a movie of cosmic evolution played in reverse. We see the universe growing younger and simpler as we look farther back in time, until we reach the cosmic microwave background, the oldest light we can observe. This ancient radiation permeates the entire observable universe, filling every cubic meter of space with photons that have been traveling since the universe was only 380,000 years old. At that time, the cosmos had cooled enough for the first hydrogen atoms to form, allowing light to travel freely for the first time in cosmic history. The cosmic microwave background is remarkably uniform, varying in temperature by only a few parts in a million across the entire sky. This uniformity tells us that the early universe was incredibly smooth and homogeneous, quite different from the clumpy, structured cosmos we inhabit today. But hidden within this uniformity are tiny fluctuations, quantum variations that existed when the universe was smaller than an atom. These microscopic differences in density provided the seeds from which all cosmic structure would eventually grow. Gravity amplified these tiny variations over billions of years, turning quantum ripples into galaxy clusters and cosmic voids. The pattern of these fluctuations, preserved in the cosmic microwave background like a cosmic fingerprint, allows us to determine fundamental properties of the observable universe with extraordinary precision. We can measure its age, its geometry, its composition, and its expansion rate with accuracies that would have seemed impossible just decades ago. These measurements reveal that we live in what's called a flat universe, one where parallel lines remain parallel forever, and the angles of triangles add up to exactly 180 degrees. This geometry implies that the observable universe could extend infinitely in all directions, with our observable sphere representing just a tiny fraction of a much larger whole. The cosmic microwave background also confirms that ordinary matter, the stuff of stars and planets and life, makes up less than 5% of the total energy density of the observable universe. The rest consists of dark matter and dark energy, those mysterious components that reveal themselves only through their gravitational effects. This brings us to one of the most humbling realizations about our cosmic home. We're not just small in terms of size, we're made of the minority component of reality. Everything we can see, touch, and interact with represents less than 1/20th of what actually exists. We're like deep-sea creatures who have never seen sunlight, trying to understand an ocean by studying the few patches of bioluminescence in their immediate vicinity. As we continue mapping and measuring the observable universe, each new discovery seems to make it stranger rather than more familiar. We find galaxies that shouldn't exist according to our models, cosmic structures that form too quickly, and expansion rates that don't match our predictions. The more we learn, the more we realize how much we still don't know, but perhaps that's exactly as it should be. A universe that revealed all its secrets easily would be a boring place indeed. The fact that each answer leads to new questions, that each discovery opens new frontiers of mystery, ensures that consciousness will always have something to explore and understand. The observable universe serves as our cosmic laboratory, our natural cathedral of wonder, our library of possibilities written in light itself. Within its 93 billion light-year expanse lies enough beauty, complexity, and mystery to inspire countless generations of explorers and dreamers. And you, right now, are part of this ongoing exploration. Every time you look up at the night sky, you're seeing the same photons that have traveled across vast reaches of space and time to reach your eyes. You're participating in a cosmic conversation that began billions of years ago and will continue long after we're gone. The question that haunts every astronomer who has ever peered deep into cosmic darkness is this: what lies beyond the edge of everything we can see? And the answer is simultaneously the most exciting and most terrifying possibility in all of science. Beyond our cosmic horizon stretches what might be an infinite expanse of space, filled with countless more galaxies, superclusters, and cosmic structures that we will never, ever be able to observe. Think about that for a moment. Right now, there could be entire civilizations out there, advanced beyond our wildest dreams, building technologies that seem like magic to us, asking the same questions about existence that keep you awake at night. But they exist in a realm so distant that no information about them can ever reach us. This isn't science fiction. This is the logical conclusion of our best understanding of cosmic expansion and the finite speed of light. The unobservable universe could be thousands, millions, or even infinitely times larger than what we can see. Every galaxy cluster we've mapped, every cosmic web filament we've discovered, might be replicated countless times in regions that remain forever hidden from our instruments. But here's where this gets absolutely mind-bending. If the universe beyond our horizon is truly infinite, then mathematics tells us something that sounds impossible but must be true. Every possible arrangement of matter and energy doesn't just exist somewhere out there. It exists infinitely many times. This means there are infinite versions of you reading these words right now. Versions where you made different choices, lived different lives, were born in different times and places. There are versions where dinosaurs never went extinct, where humans never evolved, where the laws of physics themselves take slightly different forms. In an infinite universe, not only does everything possible happen, it happens an infinite number of times. Some cosmologists have calculated that if you traveled far enough through this infinite expanse, farther than we could ever hope to go, you would eventually encounter an exact duplicate of our entire observable universe. Every atom in the same position, every galaxy following the same evolutionary path, every planet harboring the same forms of life. The distance to this cosmic duplicate is so large that writing it out would require more digits than there are atoms in our observable universe. But mathematically, if infinity is real, such duplicates must exist. You could theoretically meet another version of yourself who has lived an identical life up to this very moment, reading these exact words with the same thoughts and feelings. This possibility transforms our understanding of uniqueness and identity in ways that philosophers are still grappling with. Are you special if infinite copies of you exist? Or does the very concept of infinity make every moment, every experience, every fleeting thought infinitely precious because it's repeated infinitely throughout the cosmic expanse? The expansion of space ensures that these cosmic duplicates will remain forever beyond our reach. Dark energy, that mysterious force that makes up more than 2/3 of everything, is accelerating the expansion at an ever-increasing rate. Galaxies at the edge of our observable sphere are being carried away from us faster than light itself can travel. This creates what physicists call an event horizon. Not around a black hole, but around our entire observable region. Once a galaxy crosses this boundary, its light can never catch up to us, no matter how long we wait. We're surrounded by an expanding bubble of causality beyond which events literally cannot affect us. Future astronomers will witness this cosmic loneliness firsthand. 1 trillion years from now, if humanity or our descendants still exist, they'll look out at a night sky containing only our local cluster of galaxies. Everything else will have been carried so far away by expansion that no trace of it remains visible. They'll have no evidence that the Big Bang ever occurred, no way to discover cosmic expansion, no clue about the rich history of structure formation that we're privileged to observe today. This makes our current epoch incredibly special in cosmic history. We live at the perfect moment, old enough for complex structures to have formed and intelligent life to emerge, yet young enough to see the full majesty of cosmic evolution spread across the sky. We are cosmic archaeologists with access to evidence that will be permanently erased by the universe's own expansion. Every photon we capture from distant galaxies represents irreplaceable information about cosmic history. Every measurement we make of large-scale structure documents, patterns that future civilizations will never be able to observe. We're creating a permanent record of the universe's youth during the brief window when such observations remain possible. But the story gets even stranger when we consider what modern physics tells us about the nature of space and time themselves. Einstein's theories revealed that these aren't just empty stages where cosmic drama unfolds. They're dynamic participants in the story, capable of bending, stretching, and even breaking under extreme conditions. Near massive objects like black holes, space-time becomes so warped that time itself slows down relative to distant observers. At the event horizons of these cosmic monsters, time appears to stop entirely from an outside perspective. This means that the observable universe isn't just a collection of objects scattered through space. It's a complex web of interconnected space-time geometries, each region operating according to its own temporal rhythm. Some regions of the cosmos experience time faster than others. In the vast emptiness between galaxy clusters, where matter is sparse and gravitational fields are weak, time flows at its maximum rate. But in the dense cores of galaxy clusters, where matter warps space-time more severely, time runs slightly slower. These differences are tiny by human standards, but they accumulate over cosmic timescales. This means that the observable universe we map today represents not just a snapshot of space, but a complex mosaic of different temporal perspectives. When we observe a distant galaxy cluster, we're not just seeing it as it existed billions of years ago. We're seeing it through the lens of space-time curvature that affects how information travels from there to here. Gravitational waves, those ripples in space-time itself, first detected in 2015, add another layer to this cosmic communication network. When massive objects like black holes spiral into each other, they create disturbances that propagate through the fabric of reality at light speed. These waves carry information about some of the most violent events in cosmic history, collisions so energetic that they briefly outshine entire galaxies. The detectors that capture these gravitational waves are among the most sensitive instruments ever built, capable of measuring distortions in space smaller than 1/10,000th the width of a proton. When they detect the merger of two black holes billions of light years away, they're literally feeling the universe shake from cosmic catastrophes that occurred when Earth was still a molten ball of rock. But perhaps the most profound implication of our expanding observable universe relates to the ultimate fate of everything we can see. Current evidence suggests that dark energy will continue accelerating cosmic expansion indefinitely. This means the universe is heading toward what cosmologists call the heat death, a state where all available energy has been dispersed so thoroughly that no further work can be done. In this far future, after all the stars have burned out and all the black holes have evaporated through Hawking radiation, the observable universe will contain nothing but elementary particles scattered across infinite space. The temperature will approach absolute zero and entropy will reach its maximum possible value. It will be a cosmos of perfect equilibrium and perfect emptiness. But even this seemingly final state might not be the end of the story. Some theories suggest that quantum fluctuations in empty space could eventually create new Big Bangs, spawning baby universes that begin their own cycles of expansion and evolution. Our observable universe might be just one bubble in an eternal cosmic foam, constantly creating new realms of space and time. Other models propose that the fundamental constants of physics could change over cosmic time, altering the rules that govern how matter and energy behave. In such scenarios, the heat death might not be permanent, but rather a transition to entirely new forms of cosmic organization that we can't currently imagine. These possibilities remind us that despite all our observations and measurements, the observable universe remains fundamentally mysterious. We've mapped its large-scale structure, traced its evolutionary history, and predicted its expansion. But we still don't understand what dark matter and dark energy actually are. We don't know why the universe began with exactly the right conditions for complexity to emerge. We can't explain why consciousness arose from unconscious matter, or whether intelligence like ours is common or extraordinarily rare throughout the cosmic expanse. Every major discovery in cosmology seems to reveal new layers of mystery rather than providing final answers. When we first detected the cosmic microwave background, we thought we had found the smoking gun of the Big Bang, but studying it more carefully revealed the fine-tuning problem. The universe's initial conditions appear so precisely calibrated for complexity that many scientists struggle to explain how such perfection could arise by chance. When we discovered that galaxies are rotating too fast to be held together by the gravity of visible matter alone, we invented dark matter to explain the discrepancy. But decades of searching have failed to directly detect these mysterious particles that supposedly make up most of the matter in the observable universe. When we found that cosmic expansion is accelerating rather than slowing down, we proposed dark energy as the cause. But we have no idea what this energy actually is, or why it has exactly the right strength to dominate the universe without immediately tearing everything apart. These unsolved mysteries suggest that our picture of the observable universe, impressive as it may seem, remains embarrassingly incomplete. We're like explorers who have mapped the coastlines of continents but have barely ventured inland. The territories we've charted represent just the beginning of a much larger journey of discovery. Perhaps the most humbling aspect of studying the observable universe is realizing how brief our perspective really is. Human civilization has existed for perhaps 10,000 years, barely a blink of an eye in cosmic time. We've been looking at the universe through telescopes for only 4 centuries. We've known that other galaxies exist for less than a century. In cosmic terms, we just opened our eyes a microsecond ago. We're cosmic infants trying to understand an ancient and vast reality that has been evolving for eons before we existed and will continue evolving for eons after we're gone. The rate of cosmic change occurs on timescales so vast that the entire history of human thought represents barely a moment in the universe's ongoing transformation. Yet somehow, in this brief instant of cosmic awareness, we've managed to measure the universe's age, map its structure, and trace its history back to within moments of its birth. We've discovered that space itself is expanding, that time began with the Big Bang, and that the elements in our bodies were forged in stellar cores scattered throughout the cosmic web. This represents one of the most extraordinary achievements in the history of consciousness. A species that evolved on one small planet has managed to comprehend the structure and evolution of everything it can possibly observe. Through careful measurement and mathematical analysis, we've reconstructed the story of cosmic evolution across 13.8 billion years of history. But our journey of cosmic discovery has only just begun. New telescopes coming online will peer deeper into space and further back in time than ever before. Future gravitational wave detectors will open new windows on cosmic phenomena we haven't yet imagined. Advanced particle accelerators might finally reveal the nature of dark matter and dark energy. Each new observation adds another piece to the cosmic puzzle, while simultaneously revealing how much more remains to be discovered. The observable universe serves as both our laboratory and our inspiration, providing endless opportunities for exploration and wonder. And you, reading these words right now, are part of this ongoing cosmic story. You're made of elements forged in stellar cores throughout the observable universe. The atoms in your body have journeyed across billions of light years and billions of years to become temporarily organized into the biological structures that sustain your consciousness. Your thoughts about cosmic scale represent the universe contemplating its own vastness through neural networks that rival galaxy clusters in their complexity. Your sense of wonder at these cosmic scales embodies the universe's capacity for self-appreciation and awe. The observable universe isn't just something you study, it's the extended context of your existence, the vast cosmic environment that created the conditions necessary for your consciousness to emerge and flourish. Every breath you take connects you to interstellar processes. Every heartbeat occurs within gravitational fields that extend throughout cosmic space. When you look up at the night sky, you're not seeing distant foreign objects, but glimpsing your cosmic ancestry and extended family. The stars that guided ancient navigators are the same fusion reactors that created the heavy elements essential for life. The galaxies scattered across space represent variations on the same themes of structure and evolution that shaped our own cosmic neighborhood. In understanding how big the observable universe truly is, we discover not our insignificance, but our profound connection to everything that exists within the boundaries of space and time. We find our place not as isolated observers, but as conscious participants in the universe's ongoing project of understanding itself, through minds capable of grasping cosmic scale and appreciating cosmic beauty. The 93 billion light-year expanse of observable space contains more than distance and matter. It contains the potential for awareness itself, the capacity for wonder, the possibility of consciousness contemplating its own cosmic context. Through minds like yours, the universe achieves something that may be exceedingly rare throughout all of space and time: the ability to appreciate its own magnificence. Tonight, as we drift deeper into our exploration of cosmic immensity, we encounter something that will fundamentally alter how you perceive your relationship with existence itself. Because when we truly grasp the scale of the observable universe, we begin to understand that distance and time aren't separate concepts, but intimately woven together in ways that create the most extraordinary time machine ever discovered. Every direction you look into space is simultaneously a journey backward through time. When you gaze at the Andromeda galaxy on a clear night, you're not just seeing our nearest galactic neighbor, you're witnessing light that began its journey 2.5 million years ago, when our earliest human ancestors were just learning to walk upright across African savannas. But this is merely the beginning of our temporal voyage. The light from galaxies a few billion light years away carries messages from the universe's middle age, when star formation was reaching its cosmic peak and the large-scale structures we observe today were settling into their familiar patterns. Push your observations even further to galaxies 10 or 12 billion light years distant, and you're witnessing cosmic adolescence, a time when the universe was barely 10% of its current age. These ancient galaxies appear nothing like the mature, organized systems we see in our cosmic neighborhood. They blaze with the fury of youth, frantically converting primordial hydrogen and helium into heavy elements at rates that would exhaust a modern galaxy's fuel supply in cosmic moments. They're creating stars hundreds of times faster than the Milky Way, burning through their resources with the reckless energy of cosmic teenagers. Their light reaches us stretched and reddened by the expansion of space itself, but it still carries the signatures of this ancient stellar fury. When astronomers analyze this ancient radiation, they're reading messages from a universe that was still figuring out the basic rules of structure formation, still experimenting with different ways to organize matter into the cosmic architecture we see today. This creates something absolutely remarkable within our observable sphere. Every distance corresponds to a different chapter in the universe's autobiography. The nearby stars show us cosmic maturity. Galaxies at intermediate distances reveal the universe in its productive prime. The most distant objects transport us back to cosmic childhood, when the first stellar nurseries were just beginning to illuminate the darkness. But here's where this temporal layering becomes truly mesmerizing. Those distant galaxies we observe as cosmic teenagers have continued evolving during the billions of years their light has taken to reach us. By now, they may have transformed beyond recognition, evolved into mature systems, or even ceased to exist entirely. We're looking at a universe that no longer exists in the form we observe it. This disconnect between observation and current reality exists nowhere else in human experience. We can map the observable universe with extraordinary precision, catalogue billions of galaxies, trace cosmic evolution across vast epochs. Yet we're always looking at a reality that has already transformed into something else entirely. The expansion of space adds another layer of complexity that makes our cosmic perspective even stranger. While light from distant galaxies travels toward us at the ultimate speed limit, space itself expands between us and those sources. This means a galaxy we observe at 10 billion light-years distance has actually been carried much farther away during its light's journey to reach us. Today, that same galaxy might be 20 billion light-years away, swept to these greater distances by the relentless expansion of cosmic space. The galaxy hasn't moved through space faster than light. Space itself has grown between us, creating separations that increase every moment we contemplate them. This expansion creates what cosmologists call the cosmological redshift, a stretching of light waves that serves as our cosmic tape measure. The faster a galaxy recedes from us, the more its light gets stretched toward longer, redder wavelengths. This redshift doesn't just tell us how far away something is, it reveals how fast the space between us is expanding. The most distant galaxies we can detect show redshifts so extreme that their ultraviolet starlight has been stretched all the way into infrared wavelengths. What began as high-energy radiation from blazing young stars reaches us as low-energy infrared photons that require our most sensitive instruments to detect. We're literally watching the universe's youth through light that has been transformed by its billion-year journey through expanding space. This creates a natural timeline written across the observable universe. Each cosmic distance reveals the universe at a different age, allowing us to witness 13.8 billion years of cosmic evolution spread across the sky like pages in an enormous book. We can literally watch galaxies grow up, see how cosmic structures evolved, and trace the development of complexity from the smooth early universe to the rich tapestry of organization we observe today. But the expansion of space creates an even more profound consequence for our cosmic perspective. The acceleration of this expansion, driven by the mysterious dark energy that comprises over 2/3 of everything, means that many galaxies currently visible to us are being carried away faster and faster. Eventually, they'll recede so rapidly that their light can never catch up with the expanding space between us. These galaxies will slip beyond what physicists call our cosmic event horizon, not disappearing instantly, but fading gradually as their light becomes so redshifted that no conceivable detector could capture it. They'll join the vast majority of cosmic real estate that remains forever hidden beyond our observable boundary. This acceleration makes our current epoch extraordinarily special in cosmic history. We live at the perfect moment. The universe is old enough for complex structures to have formed and conscious observers to have emerged, yet young enough that we can still witness the full scope of cosmic evolution. Future civilizations will inherit a much lonelier cosmos. Imagine astronomers 100 billion years from now, if any exist. They'll look out at a night sky containing only our local group of galaxies, perhaps a few dozen systems bound together by gravity. Everything else will have been carried beyond their cosmic horizon by the accelerating expansion. They'll have no evidence that the Big Bang ever occurred, no way to discover cosmic expansion, no access to the cosmic microwave background that reveals the universe's fiery birth. They'll inhabit a cosmic island with no way to know that vast oceans of space and countless other islands exist beyond their reach. Their night sky will be darker, their universe will seem smaller, and the rich evidence of cosmic evolution that we can observe today will be permanently erased from their view. This temporal window makes every observation we make today incredibly precious. Every photon we capture from distant galaxies carries irreplaceable information about cosmic history. Every measurement of large-scale structure documents patterns that will eventually vanish from view. We're cosmic librarians working during the brief period when the universe's biography remains accessible to scientific investigation. The James Webb Space Telescope represents our current effort to push these boundaries as far as physically possible. By collecting infrared light, the stretched remnants of ancient starlight, it can peer deeper into space and further back in time than any previous instrument. It's designed to observe the universe when it was less than 4% of its current age, capturing light from the very first galaxies that formed after the cosmic dark ages ended. But even our most powerful instruments can only probe a fraction of what lies within our cosmic horizon. The majority of the observable universe's volume remains unexplored, not because we lack the technology, but because light from those regions simply hasn't had enough time to complete its journey to Earth yet. Every day, new regions of space cross our cosmic boundary and become observable for the first time. Ancient light that began its journey billions of years ago finally reaches our telescopes, carrying news from cosmic epochs we've never witnessed before. The observable universe grows larger by millions of miles every second, constantly revealing new chapters in the cosmic story. This ongoing expansion of our observable realm ensures that astronomy will never run out of new territories to explore. Each day brings fresh information from the early universe, new galaxies crossing into our field of view, new evidence about how cosmic structures formed and evolved. We're living participants in an ever-expanding story of cosmic discovery, but the scale of what remains hidden beyond our cosmic horizon dwarfs even our vast observable sphere. If current theories are correct, the unobservable universe could be vastly larger than what we can see, perhaps thousands, millions, or even infinitely times more extensive than our measly 93 billion light-year bubble of visibility. Think about what this means for cosmic reality. Every pattern we've discovered in the observable universe, the cosmic web of galaxy filaments, the formation of stars and planetary systems, the evolution of complexity, might be replicated countless times in regions we'll never be able to explore. The processes we study within our cosmic laboratory might represent universal principles operating throughout an infinite expanse of space. If the universe beyond our horizon is truly infinite, then mathematics compels us toward a conclusion that sounds impossible but must be true. Every possible arrangement of matter and energy occurs not just once, but infinitely many times. This includes perfect duplicates of our entire observable universe, identical down to every atom, every photon, every quantum state. Somewhere in that infinite expanse, there's another version of you contemplating these exact same cosmic scales, having identical thoughts and experiences. Not just one other version, but infinitely many, each embedded in cosmic neighborhoods that mirror our own with perfect precision. The distance to such cosmic duplicates would be so vast that expressing it would require more digits than there are particles in our observable universe. But if infinity is real, these duplicates must exist, not as science fiction speculation, but as mathematical certainty flowing from the nature of infinite possibility space. This possibility transforms every moment of existence into something simultaneously commonplace and extraordinary. If infinite versions of this moment exist throughout cosmic space, does that make it meaningless? Or does infinity itself make every experience infinitely precious because it's infinitely repeated throughout the vast expanse of reality? These questions push us toward the deepest mysteries of existence and identity. What makes you unique if perfect copies of you exist throughout infinite space? How do we understand consciousness and meaning in a reality that might contain every possible variation of experience? But regardless of what lies beyond our cosmic horizon, the observable universe provides us with enough mystery and wonder to occupy countless generations of explorers. Within its boundaries, we find evidence of processes operating on scales that challenge human comprehension, stories of cosmic evolution that span billions of years, and phenomena that reveal the fundamental principles governing all of reality. Every galaxy we observe represents a unique experiment in cosmic organization. Every star system we study offers insights into planetary formation and the conditions necessary for complexity to emerge. Every measurement we make of cosmic structure adds another piece to our understanding of how the universe organizes itself on the largest possible scales. The cosmic microwave background radiation, that ancient echo of the Big Bang, continues to yield new information about the universe's earliest moments. By analyzing tiny variations in this primordial light, we can determine fundamental cosmic properties with extraordinary precision. The universe's age, geometry, composition, and expansion rate. These measurements reveal that we inhabit what cosmologists call a flat universe, where the fundamental geometry of space follows the familiar rules we learned in school. Parallel lines remain parallel forever. The angles of triangles add up to exactly 180 degrees, and the universe could potentially extend infinitely in all directions. This flat geometry has profound implications for cosmic reality. It suggests that our observable sphere might represent just a tiny sample of a much larger whole, perhaps an infinite whole, where every possible cosmic experiment plays out somewhere in the vast expanse of space and time. But even within our finite observable realm, the diversity of cosmic phenomena exceeds our wildest imagination. We've discovered planets made of diamond-orbiting neutron stars, galaxies colliding and merging in slow-motion ballets that span hundreds of millions of years, and black holes so massive that our entire solar system could orbit within their event horizons. We've detected gravitational waves from collisions between objects so dense that a teaspoon of their material would weigh as much as a mountain. We've observed jets of matter streaming from galactic centers at nearly the speed of light, powered by black holes millions of times more massive than our sun. These extreme phenomena operate according to physics that pushes the boundaries of what we thought possible. Near black holes, time slows down relative to distant observers. In the hearts of neutron stars, matter exists in states that we can barely recreate in particle accelerators. At cosmic scales, dark energy drives an acceleration that will ultimately determine the fate of everything we can observe. Yet all of these exotic phenomena operate according to the same fundamental laws that govern processes here on Earth. The quantum mechanics that describes atomic behavior in your body also determines how matter behaves in the cores of distant stars. The gravity that keeps you anchored to our planet operates identically throughout the cosmic web, shaping galaxy clusters and determining the trajectories of light itself. This universality of physical law creates a deep connection between the most distant objects we can observe and the immediate reality of your existence. You're not separate from the cosmic phenomena we study. You're part of the same physical reality, governed by identical principles, connected through the fundamental forces that shape everything from subatomic particles to galactic superclusters. The atoms in your body were forged in stellar cores throughout the observable universe, scattered by supernova explosions, and eventually incorporated into the molecular clouds that gave birth to our solar system. You're literally assembled from stellar debris that has journeyed across billions of light years and billions of years to become temporarily organized into the biological structures that sustain your consciousness. But this connection runs deeper than material composition. The same electromagnetic forces that bind atoms together in distant galaxies also enable the chemical reactions that power your thoughts. The same nuclear processes that illuminate stars throughout cosmic space once operated in the stellar furnaces that created the heavy elements essential for your existence. When you contemplate the scale of the observable universe, you're not thinking about something foreign or distant. You're contemplating the extended context of your own existence. The vast cosmic environment that spent billions of years creating the conditions necessary for your consciousness to emerge and flourish. Every photon of starlight that reaches your eyes has traveled across this cosmic expanse to deliver its ancient message. Every breath you take participates in chemical cycles that connect you to interstellar processes. Every heartbeat occurs within gravitational fields that extend throughout the observable universe, linking you to every massive object within our cosmic horizon. The neural networks in your brain rival galaxy clusters in their complexity, processing information through patterns of connection that mirror the cosmic web itself. Your thoughts about cosmic scale represent the universe contemplating its own vastness through biological structures that embody the same organizational principles operating throughout cosmic space. This perspective transforms your relationship with the observable universe from detached observation to intimate participation. You don't simply study cosmic phenomena from the outside. You're embedded within the same reality, shaped by identical processes, contributing to the universe's ongoing evolution toward greater complexity and understanding. Through consciousness like yours, the observable universe achieves something that may be extraordinarily rare throughout all of cosmic space and time: the capacity to appreciate its own magnificence. Your sense of wonder at cosmic scales embodies the universe's ability to marvel at its own creative achievements. Your questions about existence and meaning channel the fundamental mystery that underlies all of reality. As we continue this journey through cosmic scales, we find ourselves approaching territories that challenge our most basic assumptions about the nature of space, time, and existence itself. The observable universe reveals itself not just as a collection of distant objects, but as a living, dynamic system that connects every conscious moment to the deepest structures of reality. The story becomes even more profound when we realize that our observable universe exists within what might be the most elegant cosmic architecture ever conceived. Scientists have discovered that the large-scale structure of reality follows patterns that seem almost too perfect to be accidental. The cosmic web that stretches across billions of light years resembles neural networks in biological brains, with galaxy clusters serving as nodes connected by vast filaments of dark matter. This similarity isn't just poetic coincidence. It suggests that the same organizational principles that govern consciousness might operate throughout cosmic space itself. The pathways that thoughts travel in your mind mirror the highways that matter follows through intergalactic space. The information processing that happens in your brain reflects patterns that emerge naturally when gravity shapes matter across the largest scales we can measure. When neuroscientists map the connections between brain cells and cosmologists chart the distribution of galaxies, they discover structures that are mathematically identical despite differing in scale by factors of trillions. Your thoughts might literally follow the same geometric patterns that organize reality throughout the observable universe. But this architectural beauty extends even deeper into the quantum realm. The tiny fluctuations that existed when the universe was smaller than an atom eventually grew into the galaxy clusters we observe today. Quantum uncertainty at the smallest possible scales became cosmic certainty at the largest scales we can measure. The universe bootstrapped itself from quantum foam into cosmic web through processes that operate like a vast amplification system. These quantum seeds of structure were stretched by cosmic inflation, a period of exponential expansion that occurred in the first tiny fraction of a second after the Big Bang. During this brief moment, space itself grew faster than light could travel, taking microscopic variations and inflating them to sizes larger than our current observable horizon. It's as if the universe took quantum whispers and amplified them into cosmic symphonies. This inflationary process created regions of space that are now forever beyond our ability to observe. The same mechanism that seeded the structures we see also created vast territories that remain permanently hidden beyond our cosmic event horizon. We might be living in just one inflated patch among countless others, each with its own unique properties and evolutionary history. Think about what this means for cosmic reality. The observable universe might represent just one bubble in an infinite cosmic foam, where each bubble contains its own version of physics, its own evolutionary story, its own potential for complexity and consciousness. Some bubbles might have different values for fundamental constants, making chemistry impossible. Others might have conditions so perfect for structure formation that they teem with galaxies and stars beyond our wildest imagination. This possibility transforms our cosmic perspective once again. Not only are we small compared to our observable universe, but our entire observable universe might be infinitesimally small compared to the full extent of reality. Every measurement we make, every discovery we achieve, might apply only to our local cosmic neighborhood, a region that seems vast to us, but could be microscopic within the larger scheme of existence. Yet this potential cosmic humility brings with it an extraordinary realization about the nature of consciousness itself. In a reality that might contain infinite variations and infinite possibilities, the emergence of awareness capable of contemplating its own cosmic context becomes even more remarkable. Your ability to grasp these scales and wonder about these possibilities represents something that transcends any simple measurement of size or distance. The information processing happening in your brain right now involves quantum mechanical processes that connect to the fundamental nature of reality itself. Every thought you have about cosmic scale emerges from quantum interactions between particles that were forged in stellar cores throughout the observable universe. The very act of contemplating infinity involves biological structures that embody the same mathematical relationships governing cosmic architecture. This creates a beautiful, recursive loop where the universe uses parts of itself to understand itself. Through consciousness, cosmic matter achieves the remarkable feat of self-reflection. The same atoms that were scattered by ancient supernovas have organized themselves into patterns capable of comprehending the supernovas that created them. You are the observable universe becoming aware of its own existence and marveling at its own creative potential. But the story of cosmic scale takes another mind-bending turn when we consider what modern physics tells us about the nature of information itself. Recent discoveries suggest that all the information contained within any volume of space might actually be encoded on that volume's boundary, like a cosmic hologram where three-dimensional reality emerges from two-dimensional information. If this holographic principle applies to the observable universe as a whole, then everything we've discussed, every galaxy, every star, every quantum process, might be projections from information encoded on a two-dimensional surface at the edge of our cosmic horizon. Reality, as we experience it, could be a holographic representation of more fundamental information existing in fewer dimensions than we can perceive. This possibility doesn't make our experience any less real, but it suggests that reality itself might be far stranger than even our most exotic cosmological theories predict. The observable universe might be simultaneously exactly what it appears to be, and something completely different operating according to principles we're only beginning to glimpse. The holographic principle also implies that there might be absolute limits to how much information any region of space can contain. These limits depend on the area of the region's boundary rather than its volume, creating a cosmic speed limit for information density that applies throughout the observable universe. This connects the larger scales we can measure to the smaller scales that quantum mechanics permits. Every black hole in the observable universe operates according to these holographic principles. The information that falls past their event horizons doesn't disappear, but becomes encoded on their two-dimensional surfaces. The larger the black hole, the more information it can store, but always in proportion to its surface area, never its volume. These cosmic information storage devices might preserve detailed records of everything that has ever fallen into them throughout billions of years of cosmic history. Some theorists propose that our entire observable universe might function like a vast black hole when viewed from outside. If this is true, then all the information describing our cosmic reality, every galaxy, every star, every moment of consciousness, might be encoded on a distant boundary that exists in dimensions we cannot directly perceive. This brings us to one of the most startling implications of modern cosmic research. The observable universe might not just be large beyond human comprehension. It might be embedded within higher dimensional structures that make our three-dimensional experience seem as limited as a shadow on a wall. Just as a two-dimensional being living on a sheet of paper couldn't directly perceive the three-dimensional room containing their world, we might be unable to directly experience the higher dimensional reality that contains our observable universe. String theory and other advanced physics frameworks suggest that reality might operate in as many as 11 dimensions. with most of them curled up so tightly that they remain invisible at the scales we can observe. These hidden dimensions might be where the fundamental forces of nature actually operate, with what we experience as gravity, electromagnetism, and nuclear forces being mere shadows of higher dimensional phenomena. If these theories are correct, then asking, how big is the observable universe might be like asking, how long is the shadow of a skyscraper, while remaining unaware that skyscrapers have height and depth as well as length. We might be measuring just one aspect of a cosmic reality that extends through dimensions our instruments cannot detect, and our minds struggle to imagine. The mathematics that describes these higher dimensional possibilities operates with precision and elegance that rivals anything we observe in the three-dimensional structures of the cosmic web. These equations suggest that what we interpret as separate forces, gravity warping space-time, quantum fields creating particles, dark energy accelerating expansion, might all be aspects of unified phenomena operating in dimensions beyond our direct perception. This unified picture of reality would make the observable universe even more remarkable than we already understand it to be. Every quantum interaction in your brain, every fusion reaction in distant stars, every gravitational wave rippling through space would be connected through higher dimensional structures that bind all of cosmic reality into a single coherent whole. But even if our observable universe exists within higher dimensional frameworks that dwarf our current understanding, it remains the stage upon which the most extraordinary phenomenon we know, consciousness itself, has emerged and flourished. The neural networks in your brain that allow you to contemplate these cosmic possibilities represent an achievement that might be vanishingly rare throughout all the dimensions and scales that reality encompasses. The emergence of awareness capable of grasping cosmic scale might be the universe's greatest accomplishment, regardless of how many dimensions it actually possesses or how much larger it might be than we can currently observe. Through consciousness, reality achieves the capacity to appreciate its own beauty, understand its own structure, and wonder about its own ultimate nature. Your thoughts about cosmic scale represent information processing capabilities that rival anything we observe in the cosmic web itself. The approximately 86 billion neurons in your brain create a network of connections that approaches the complexity of galaxy clusters, processing information through patterns that mirror the largest structures we can map in observable space. When you contemplate the possibility of higher dimensions or infinite cosmic expanses, you're using biological quantum computers that embody the same mathematical principles governing reality throughout all scales and dimensions. Your capacity for wonder at cosmic immensity demonstrates that consciousness itself might be the most sophisticated information processing system the universe has developed. This realization transforms our understanding of cosmic significance in ways that transcend simple measurements of size or scale. While we might be infinitesimally small compared to cosmic structures, and our observable universe might be infinitesimally small compared to higher dimensional reality, consciousness represents something that cannot be measured by spatial dimensions alone. Awareness operates through principles that connect quantum mechanics to cosmic architecture, linking the smallest possible scales to the largest structures we can observe. Through consciousness, the universe develops the capacity to understand itself from the inside, to appreciate its own creative achievements, and to ask questions about its own ultimate nature and purpose. The observable universe serves as our laboratory for exploring these deep connections between mind and cosmos. Every measurement we make of cosmic structure reveals mathematical relationships that also govern the neural processes enabling those measurements. Every discovery about cosmic evolution illuminates principles that also determine how consciousness emerges from unconscious matter. As we map the cosmic web spanning billions of light years, we simultaneously chart territories of possibility that exist within our own minds. The same organizational principles that create galaxy clusters also enable the thoughts you're having right now about cosmic scale and cosmic meaning. Reality reveals itself as a unified whole, where the largest and smallest scales interpenetrate through structures of breathtaking mathematical elegance. Tonight, as you contemplate these cosmic scales and higher dimensional possibilities, remember that you embody the universe's most remarkable achievement, the emergence of awareness capable of grasping infinity itself. Your consciousness represents reality, becoming self-aware, cosmic matter, achieving the capacity to understand its own existence and wonder about its own ultimate destiny. The observable universe surrounds you, not as empty space punctuated by distant objects, but as an integrated information system of which your consciousness forms an essential component. Every thought you have about cosmic scale participates in the universe's ongoing project of self-understanding, adding your unique perspective to reality's growing comprehension of its own infinite depths and magnificent possibilities. In measuring the size of the observable universe, we discover something far more profound than distance or scale. We uncover the extraordinary nature of consciousness itself and its role in reality's ongoing evolution toward greater complexity, beauty, and self-awareness. The cosmos reveals itself not just as vast beyond imagination, but as meaningful beyond measure. A reality where awareness and architecture dance together in patterns that connect the quantum realm to cosmic space through structures of infinite wonder and eternal mystery. Tonight, as we venture deeper into this cosmic expedition, we encounter something that will fundamentally transform how you understand the relationship between observation and reality itself. Because the observable universe doesn't just present us with a collection of distant objects scattered through space. It reveals the most sophisticated time machine ever discovered, operating on principles so elegant they seem almost too perfect to be real. Every photon that reaches your eyes from a distant star carries within it not just light, but time itself. When you gaze up at the constellation Orion on a winter evening, you're simultaneously looking at multiple moments in cosmic history. Betelgeuse, that red giant marking Orion's shoulder, shows you light that departed roughly 700 years ago, when medieval cathedrals were still rising across Europe. The stars in Orion's belt reveal themselves as they existed between 800 and 2000 years ago, their ancient light crossing the vast emptiness to paint pictures of the past across your retina. But this is merely the shallow end of our cosmic time machine. Push your vision beyond individual stars to entire galaxies, and you're peering into epochs so remote they predate not just human civilization, but complex life itself. The Andromeda Galaxy, visible as a faint smudge to the naked eye, presents you with photons that began their journey when our ancestors were still learning to control fire. Every distant galaxy cluster reveals the universe as it existed when Earth was nothing more than cosmic dust, orbiting a young sun in a galaxy still finding its mature form. This creates something absolutely extraordinary within our observable realm, a natural archive where every moment of cosmic history since the universe became transparent remains accessible to careful observation. We don't need to imagine what the early cosmos looked like. We can literally see it by pointing our telescopes toward increasingly distant objects. The universe has preserved its own biography in light, scattered across space like pages from an enormous book written in wavelengths our instruments can decode. The most distant galaxies currently detectable appear as they existed when the universe was barely 5% of its current age. Cosmic infants blazing with the fury of first-generation star formation. These ancient systems converted primordial hydrogen and helium into heavier elements at rates that would exhaust modern galaxies within cosmic moments. They represent the universe learning how to build complexity from simplicity, experimenting with different architectural approaches to organizing matter into the structured cosmos we observe today. But here's where this temporal layering becomes truly mind-bending. Those distant galaxies we observe in their youth have continued evolving throughout the billions of years their light has traveled to reach us. By now, they may have matured into sophisticated spiral systems, merged with neighboring galaxies, or even dispersed their stellar populations back into intergalactic space. We're mapping a universe that exists only in the past tense, documenting cosmic adolescence, while the same regions have long since reached maturity. This disconnect between observation and current reality creates a unique form of cosmic archaeology. Every measurement we make captures information about processes that concluded eons ago. Every spectrum we analyze reveals chemical compositions that have likely transformed beyond recognition. We're studying fossil light from a universe that has already evolved into something entirely different. The expansion of space itself adds another layer of complexity to this temporal puzzle. While ancient light journeys toward us at the ultimate cosmic speed limit, the very fabric of space continues stretching between us and distant sources. This means objects we observe at specific distances have actually been carried much farther away by the time their light completes its journey to our detectors. Consider a galaxy we observe at 10 billion light-years distance. That galaxy emitted its light when the universe was roughly 3 billion years old. But during the 10 billion years that light has traveled to reach us, cosmic expansion has swept that same galaxy to perhaps 20 billion light-years away. The source of the light we're analyzing today exists in a completely different cosmic neighborhood than when it originally generated those photons. This expansion creates what cosmologists call look-back time, the difference between when we observe something and when the light we're seeing was actually emitted. For the most distant objects in our observable sphere, look-back time approaches the age of the universe itself. We're literally seeing these systems as they appeared shortly after the cosmic dark ages ended and the first stars began illuminating space. The stretching of space also transforms the light itself during its billion-year journey. Wavelengths get pulled longer by cosmic expansion, shifting originally blue and ultraviolet starlight into red and infrared frequencies by the time it reaches our instruments. This cosmological redshift serves as our primary tool for measuring cosmic distances and determining how rapidly different regions of space are receding from us. The most extreme redshifts we can currently detect correspond to light that has been stretched by factors of 10 or more. Ultraviolet radiation from hot young stars reaches us as infrared photons that require our most sensitive space-based telescopes to capture. we're detecting the transformed echoes of stellar nurseries that blazed with intensities unimaginable in today's mature cosmic environment. This natural redshift creates a cosmic spectrum analyzer that reveals not just distances, but velocities, temperatures, chemical compositions, and evolutionary states of objects throughout our observable sphere. Each wavelength carries encoded information about the physical processes operating in distant stellar systems, allowing us to reconstruct detailed histories of cosmic evolution across 13.8 billion years of universal development. But the expansion of space creates an even more profound implication for our cosmic perspective. The acceleration of this expansion, driven by dark energy's mysterious influence, means that objects at the edge of our current observable horizon are being carried away from us at speeds approaching the velocity of light itself. Eventually, they'll cross what physicists call the cosmic event horizon, the boundary beyond which their light can never catch up with the expanding space between us. This creates a kind of cosmic censorship where entire regions of reality slip permanently beyond our ability to observe. Galaxies that we can study today will gradually fade from view as their light becomes so redshifted that no conceivable detector could capture it. They'll join the vast majority of cosmic space that remains forever hidden beyond our observable boundary. Future astronomers will inherit a progressively lonelier universe. The rich tapestry of cosmic structure that we can map today will slowly disappear from their night sky, erased not by any catastrophic event, but by the patient work of accelerating expansion, carrying evidence of cosmic history beyond the reach of observation. In 100 billion years, if conscious observers still exist, they'll see only our local cluster of galaxies surrounded by seemingly empty space. They'll have no way to discover that cosmic expansion exists, no evidence that the universe had a beginning, no access to the cosmic microwave background that reveals the universe's fiery birth. The abundant evidence of cosmic evolution that guides our current understanding will be permanently lost to future civilizations, making our present epoch extraordinarily precious in the timeline of cosmic knowledge. This temporal limitation transforms every photon we capture from distant galaxies into irreplaceable historical evidence. Every measurement we make of large-scale cosmic structure documents patterns that will eventually vanish from view. We're working as cosmic historians during the brief period when the universe's autobiography remains accessible to scientific investigation. The James Webb Space Telescope represents our current attempt to push these observational boundaries as far as physically possible. By collecting infrared light, the redshifted remnants of ancient ultraviolet and visible radiation, it can peer deeper into cosmic time than any previous instrument. It's designed to observe the universe during its first billion years, capturing light from the epoch when the cosmic dark ages were ending and the first stellar nurseries were beginning to illuminate space. But even our most ambitious instruments can explore only a fraction of what lies within our cosmic horizon. The majority of the observable universe's volume remains uncharted territory, not because we lack the technology to observe it, but because light from those regions is still in transit, crossing the vast distances that separate us from the most remote corners of our cosmic sphere. Every second, new regions of space cross into our observable realm as their ancient light finally completes its multi-billion-year journey to Earth. We're living participants in an expanding story of cosmic discovery, with fresh chapters constantly arriving from the depths of space and time. The observable universe grows larger every moment, revealing new territories that have been racing toward us since shortly after the Big Bang itself. This ongoing expansion of our cosmic horizon ensures that astronomy will never exhaust its territories of exploration. Each day brings new information from previously unobservable regions, new galaxies crossing into our field of view, new evidence about how the universe organized itself during its earliest epochs. We're witnessing the universe's own timeline unfold in real time, as ancient light finally bridges the cosmic distances that have kept remote regions hidden from our view. But the scale of what remains beyond our cosmic event horizon dwarfs even our vast observable sphere. Current theories suggest that the unobservable universe could extend far beyond what we can detect, perhaps thousands, millions, or even infinitely times larger than our 93 billion light-year bubble of visibility. Every cosmic structure we've mapped might be replicated countless times in territories that will forever remain beyond our ability to explore. If the universe beyond our horizon extends infinitely, then mathematics compels us toward conclusions that sound impossible but must be true. Every possible arrangement of matter and energy would exist not just once, but infinitely many times throughout cosmic space. This includes perfect duplicates of our entire observable universe, identical in every detail down to individual atoms and quantum states. Somewhere in that infinite expanse would exist another version of you, experiencing this exact moment of cosmic contemplation, processing identical thoughts about the scale of reality. Not just one such duplicate, but infinitely many variations, each embedded in cosmic environments that mirror our own with mathematical precision. The distance to such cosmic twins would be so vast that expressing it numerically would require more digits than exist in our entire observable sphere. This possibility transforms every moment of existence into something simultaneously unique and universal. If infinite copies of this moment exist throughout space, does that diminish its significance? Or does infinity itself make every experience infinitely precious because it's infinitely replicated throughout the boundless expanse of cosmic possibility? These questions push us toward the deepest mysteries of consciousness and identity. What makes your particular experience special if perfect duplicates exist throughout infinite space? How do we understand meaning and purpose in a reality that might contain every conceivable variation of existence? But regardless of what lies beyond our cosmic horizon, the observable universe provides more than enough mystery and wonder to occupy countless generations of explorers. Within its boundaries, we discover processes operating on scales that challenge human comprehension, evolutionary stories spanning billions of years, and phenomena that reveal fundamental principles governing all of reality. The cosmic microwave background radiation continues yielding new insights about the universe's earliest accessible moments. By analyzing minute variations in this ancient light, we can determine cosmic properties with extraordinary precision, revealing not just the universe's age and composition, but also the quantum fluctuations that seeded all later structure formation. These measurements confirm that we inhabit what cosmologists call a flat universe, where space follows the familiar geometric rules we learned in mathematics classes. This flatness has profound implications, suggesting that our observable sphere might represent just a tiny sample of a potentially infinite whole. where every possible cosmic experiment plays out somewhere in the vast expanse of space and time. Within our finite observable realm, the diversity of cosmic phenomena exceeds our wildest imagination. We've discovered diamond planets orbiting pulsar stars, galaxy mergers unfolding across hundreds of millions of years, and black holes so massive that entire solar systems could orbit within their gravitational influence. We've detected ripples in space-time itself, from collisions between objects so dense that teaspoons of their material would outweigh mountains. These extreme phenomena operate according to physics that pushes the boundaries of what seems possible, yet they follow the same fundamental laws that govern processes here on Earth. The quantum mechanics describing atomic behavior in your body also determines how matter behaves in stellar cores billions of light years away. The gravity anchoring you to our planet operates identically throughout the cosmic web, shaping the largest structures we can observe. This universality of physical law creates profound connections between distant cosmic phenomena and your immediate existence. You're not separate from the cosmic processes we study, but part of the same physical reality, governed by identical principles, connected through forces that operate from subatomic scales to cosmic superclusters. The heavy elements in your body originated in stellar furnaces throughout the observable universe, scattered by supernova explosions, and eventually incorporated into the molecular clouds that birthed our solar system. You're assembled from cosmic debris that has journeyed across billions of light years and billions of years to become temporally organized into biological structures supporting your consciousness. Your neural networks rival galaxy clusters in their complexity, processing information through connection patterns that mirror the cosmic web itself. Your thoughts about cosmic scale represent the universe contemplating its own vastness through biological quantum computers that embody the same mathematical relationships governing reality throughout space and time. When you gaze up at the night sky, you're not observing foreign objects, but witnessing your cosmic ancestry and extended family. The stars that guided ancient navigators are the same fusion reactors that created elements essential for your existence. The galaxies scattered across space represent variations on the same organizational themes that shaped our local cosmic environment. This perspective transforms your relationship with the observable universe from detached study to intimate participation. You don't simply examine cosmic phenomena from outside, but exist embedded within the same reality, shaped by identical processes, contributing to the universe's ongoing evolution toward greater complexity and understanding. Through consciousness like yours, the observable universe achieves something that may be extraordinarily rare throughout all of space and time: the capacity to appreciate its own magnificence. Your sense of wonder at cosmic scales embodies reality's ability to marvel at its own creative achievements. Your questions about existence channel the fundamental mystery underlying all cosmic phenomena. The 93 billion light-year expanse contains more than distance and matter. It contains the potential for awareness itself, the capacity for wonder, the possibility of consciousness contemplating its own cosmic context. Through minds capable of grasping these scales, reality becomes self-aware, achieving the remarkable feat of understanding its own structure and marveling at its own infinite creative potential. As we continue mapping this cosmic architecture, we discover that our journey has only just begun. Each answer we uncover generates new questions that guide further exploration, Each mystery we solve reveals deeper mysteries that challenge our theoretical frameworks and observational capabilities. The observable universe responds to our growing understanding by revealing new layers of complexity and beauty that ensure the journey of cosmic discovery will continue far beyond our current capabilities. Tonight, as ancient starlight continues its billion-year journey to reach your eyes, as cosmic expansion stretches the fabric of space around you, as quantum processes maintain the molecular machinery supporting your awareness, you rest within the embrace of the greatest story ever told. The story of how reality learned to understand itself through minds capable of grasping infinity and appreciating the magnificent mystery of cosmic existence itself. Tonight, as we approach the crescendo of our cosmic journey, we encounter something that will fundamentally shatter every assumption you've ever held about the nature of reality itself. Because the observable universe isn't just incomprehensibly vast, it might be revealing something about the very fabric of existence that makes even our wildest science fiction seem quaint by comparison. Picture this: everything we've explored together, every galaxy cluster spanning hundreds of millions of light years, every cosmic web filament stretching across billions of light years, every mind-bending scale we've contemplated, all of it might exist as information encoded on a two-dimensional surface at the edge of our cosmic horizon. Like the most sophisticated hologram ever conceived, our three-dimensional reality could be a projection from data stored in fewer dimensions than we can directly perceive. This isn't mystical speculation. This is cutting-edge physics, suggesting that the observable universe operates according to principles so counterintuitive they redefine what we mean by the word real. The holographic principle proposes that every bit of information contained within any volume of space can be encoded on that volume's boundary, meaning everything you've ever experienced, every thought you've ever had, every star you've ever seen exists as patterns on a cosmic surface located at distances so remote they approach the edge of everything. But here's where it gets absolutely mind-melting. If this principle applies to our entire observable sphere, then the 93 billion light-year expanse we've been exploring might be a three-dimensional shadow cast by two-dimensional information. Reality as you experience it could be fundamentally different from reality as it actually exists. Not less real, but real in ways that transcend our everyday understanding of what reality means. Think about what this implies for your own existence, your consciousness, your memories, your capacity to contemplate these cosmic scales. All of it might emerge from information patterns encoded on a surface so distant that light from it will never reach us. You could be both exactly who you think you are and simultaneously something completely different, operating according to principles that make our normal concepts of space and time seem like crude approximations. This holographic nature of reality connects to something even more profound about the observable universe. Every black hole we've discovered operates according to these same principles. The information that falls past their event horizons doesn't vanish, but becomes encoded on their two-dimensional surfaces. The larger the black hole, the more information it can store, but always proportional to its surface area, never its volume. These cosmic information storage devices preserve detailed records of everything that has ever crossed their boundaries. Every star that has been consumed, every particle that has spiraled inward, every bit of cosmic history that has vanished beyond their event horizons, remains encoded in patterns we're only beginning to understand. Black holes serve as the universe's ultimate archives, maintaining perfect records across billions of years of cosmic evolution. Some theorists propose that our entire observable universe functions like a vast black hole when viewed from outside perspectives we cannot access. If true, then all the information describing our cosmic reality, every galaxy, every quantum interaction, every moment of consciousness, might be encoded on boundaries that exist in dimensions beyond our direct perception. This brings us face to face with possibilities that make even our exploration of cosmic scale seem limited. The observable universe might be embedded within higher dimensional structures that render our three-dimensional experience as constrained as a shadow on a wall. String theory suggests reality operates in as many as 11 dimensions, with most curled up so tightly they remain invisible at scales we can detect. These hidden dimensions might be where fundamental forces actually originate. What we experience as gravity warping space-time, electromagnetic fields binding atoms, or nuclear forces powering stars could be mere shadows of higher dimensional phenomena operating according to principles our instruments cannot directly measure and our minds struggle to visualize. If these theories prove correct, then asking, how big is the observable universe, becomes like asking, how long is a shadow, while remaining unaware that objects casting shadows possess height and depth, as well as length. We might be measuring just one aspect of cosmic reality that extends through dimensions our current physics can barely describe. The mathematics governing these higher dimensional possibilities operates with elegance that rivals anything we observe in cosmic architecture. These equations suggest that phenomena we interpret as separate, space-time curvature, quantum field fluctuations, dark energy acceleration, might all be aspects of unified processes operating in dimensions beyond our immediate perception. This unified picture would make the observable universe even more remarkable than we've already discovered. Every quantum interaction in your brain, every fusion reaction in distant stars, every gravitational wave rippling through space, would connect through higher dimensional structures, binding all cosmic reality into a single, coherent whole. But regardless of how many dimensions reality actually possesses, consciousness remains the most extraordinary phenomenon we encounter. The neural networks enabling your contemplation of these possibilities represent achievements that might be vanishingly rare throughout all the scales and dimensions reality encompasses. Your brain contains roughly 86 billion neurons, creating connection patterns that rival galaxy clusters in their complexity. When you contemplate higher dimensional reality or infinite cosmic expanses, you're using biological quantum computers embodying the same mathematical principles governing reality throughout all scales. Your capacity for wonder at cosmic immensity demonstrates that consciousness might be the universe's most sophisticated information processing achievement. This realization transcends simple measurements of size or scale. While we might be infinitesimally small compared to cosmic structures, and our observable universe might be microscopic, within higher dimensional reality, consciousness operates through principles connecting quantum mechanics to cosmic architecture, linking the smallest scales to the largest structures we can observe. Through awareness, the universe develops capacity to understand itself from within, to appreciate its own creative achievements, and to ask questions about its ultimate nature. The observable universe serves as our laboratory for exploring connections between mind and cosmos, revealing mathematical relationships that govern both neural processes and galactic evolution. As we map cosmic webs spanning billions of light years, we simultaneously chart territories of possibility existing within consciousness itself. The same organizational principles creating galaxy clusters enable thoughts you're having right now about cosmic meaning. Reality reveals itself as unified wholeness, where largest and smallest scales interpenetrate through structures of breathtaking mathematical elegance. The expanding nature of our observable horizon ensures this journey of discovery continues indefinitely. Every second brings new regions into our cosmic view as ancient light completes journeys that began billions of years ago. We're living participants in an ever-expanding story, where each answer generates new questions, guiding further exploration. Modern instruments push observational boundaries toward physical limits. The James Webb Space Telescope captures infrared remnants of ultraviolet radiation from cosmic dawn. Gravitational wave detectors sense space-time ripples from black hole collisions. Radio telescopes decode signals from phenomena operating under conditions that don't exist anywhere in our solar system. Each technological advance reveals new layers of cosmic complexity, while simultaneously showing how much remains unknown. We've mapped large-scale structure and measured fundamental properties with extraordinary precision. Yet dark matter and dark energy remain largely mysterious despite decades of intensive research. Recent observations challenge our models in unexpected ways. Galaxies that formed earlier than predicted, black holes that grew larger than anticipated, cosmic structures exhibiting properties we hadn't expected. These surprises remind us that cosmic reality continues exceeding our theoretical frameworks, ensuring astronomy will never exhaust its territories of mystery. The observable universe responds to our growing understanding by revealing phenomena that keep pushing boundaries of what seems possible. Planets made of diamond-orbiting pulsar stars, galaxy mergers unfolding across hundreds of millions of years, black holes so massive that entire solar systems could orbit within their gravitational influence. These extreme phenomena operate according to physics that challenges our assumptions about reality's limits, yet they follow identical fundamental laws governing processes here on Earth. The universality of physical principles creates profound connections between the most exotic cosmic phenomena and your immediate existence. You're assembled from elements forged in stellar cores throughout the observable universe, scattered by supernova explosions, eventually incorporated into molecular clouds that birthed our solar system. Your existence represents billions of years of cosmic evolution, stellar nucleosynthesis, planetary formation, and biological development, culminating in awareness capable of contemplating its own cosmic context. The electromagnetic forces binding atoms in distant galaxies operate identically to those enabling chemical reactions powering your thoughts. The nuclear processes illuminating stars throughout cosmic space once operated in stellar furnaces that created elements essential for your biological existence. When you contemplate cosmic scale, you're not thinking about something foreign, but examining the extended context of your own existence. Every photon reaching your eyes has traveled across cosmic expanses to deliver ancient messages. Every breath connects you to interstellar processes. Every heartbeat occurs within gravitational fields extending throughout observable space. Your neural networks process information through patterns mirroring cosmic web architecture. Your thoughts about reality represent the universe contemplating its own nature through biological structures, embodying organizational principles, operating throughout cosmic space. This perspective transforms your relationship with observable reality from detached observation to intimate participation. You don't simply study cosmic phenomena from outside, but exist embedded within identical reality, shaped by the same processes, contributing to ongoing cosmic evolution toward greater complexity and understanding. Through consciousness like yours, the observable universe achieves something extraordinarily rare: capacity to appreciate its own magnificence. Your sense of wonder embodies reality's ability to marvel at its own creative achievements. Your questions about existence channel fundamental mystery underlying all cosmic phenomena. The observable universe contains more than matter and energy. It contains potential for awareness itself, capacity for wonder, possibility of consciousness contemplating its own cosmic context. Through minds capable of grasping these scales, reality becomes self-aware, achieving remarkable feats of self-understanding and appreciation for its own infinite creative potential. Tonight, as you rest within this cosmic context, remember that consciousness represents something that cannot be measured by spatial dimensions alone, but connects quantum mechanics to galactic architecture through structures of infinite elegance and eternal mystery. The journey through cosmic scale reveals not just the size of space, but the magnitude of awareness itself and the extraordinary privilege of participating in reality's ongoing evolution toward greater complexity, beauty, and self-understanding. In measuring the observable universe, we discover something far more profound than distance. We uncover the remarkable nature of consciousness and its role in cosmic self-awareness. As ancient starlight continues its billion-year journey to reach your awareness, as cosmic expansion stretches reality's fabric around you, as quantum processes maintain molecular machinery supporting consciousness, you exist at the heart of the greatest story ever told. How the universe learned to know itself through minds capable of grasping infinity and marveling at the magnificent mystery of existence itself. The story becomes even more profound when we consider what happens at the very edge of our cosmic vision. At the furthest boundaries of what we can observe lies something that will make your understanding of time itself completely collapse. Because when we peer toward the cosmic microwave background, that ancient afterglow of creation, we're not just looking at the oldest light in the universe. We're approaching the moment when time and space themselves first learned the rules they would follow for the next 14 billion years. This ancient radiation fills every cubic centimeter of space around you right now. As you sit there contemplating these scales, you're bathed in photons that have been journeying since the universe was only 380,000 years old. These particles of light have witnessed the entire history of cosmic evolution, traveling through space while galaxies formed, stars ignited, and planets coalesced from stellar debris. But here's what makes this truly extraordinary. Before this moment of cosmic transparency, the universe was completely opaque to light. Imagine trying to see through the densest fog imaginable, where photons couldn't travel more than a few meters without colliding with free electrons. The entire cosmos was like the interior of a star, so hot and dense that light couldn't propagate freely through space. Then, in a cosmic instant, everything changed. As the universe expanded and cooled, electrons and protons suddenly combine to form the first neutral atoms. The cosmic fog lifted and light was free to travel unimpeded across space for the first time. This moment of first transparency created the oldest baby picture of the universe we can ever hope to see. What's remarkable is how smooth this ancient light appears across the entire sky. The temperature variations are incredibly tiny, just a few millionths of a degree. This tells us something profound about the early universe. It was far more uniform and homogeneous than the clumpy, structured cosmos we inhabit today. Yet hidden within this smoothness are the quantum seeds that would eventually grow into every galaxy cluster, every cosmic web filament, every structure we observe today. These tiny fluctuations represent quantum uncertainty amplified to cosmic proportions. During the first fraction of a second after the Big Bang, space itself expanded faster than light could travel, stretching microscopic quantum variations to sizes larger than our current observable horizon. It's as if the universe took quantum whispers and turned them into cosmic symphonies that still echo through space today. This process of cosmic inflation didn't just create the structures we see. It also created vast territories beyond our cosmic horizon that we can never hope to observe. The same mechanism that seeded our observable universe also generated countless other regions, each potentially with different properties, different evolutionary histories, different possibilities for complexity to emerge. Think about the implications. Our entire observable universe, with all its trillions of galaxies and incomprehensible vastness, might represent just one tiny patch in an exponentially larger inflated reality. Beyond our cosmic boundary could lie regions where the laws of physics take different forms, where fundamental constants have different values, where entirely alien forms of organization and complexity have emerged. Some of these regions might be so different from our own that chemistry as we know it couldn't exist. Others might be so perfectly tuned for structure formation that they teem with galaxies and stars beyond our wildest imagination. Still, others might contain forms of matter and energy so exotic that we don't even have concepts to describe them. This inflationary multiverse would make our observable universe seem like a single bubble in an infinite cosmic foam. Each bubble might contain its own version of physics, its own story of evolution, its own potential for consciousness to emerge and contemplate its cosmic context. We could be living in just one possibility among an infinite array of cosmic realities. But even if infinite variations exist beyond our horizon, they remain forever inaccessible to direct observation. The observable universe defines absolute limits to what we can ever know about reality through empirical investigation. Everything beyond our cosmic boundary exists in the realm of theory and mathematical inference, no matter how well-founded that inference might be. This creates a beautiful tension between the known and unknowable. We can map our observable realm with increasing precision, but we can never escape the fundamental boundaries that define our cosmic perspective. We're explorers on an island of knowledge surrounded by an ocean of mystery that grows larger relative to our understanding with each passing moment. The expansion of space ensures that this ocean of mystery continues expanding faster than we can explore it. Dark energy, that mysterious force comprising over 2/3 of everything, accelerates cosmic expansion at an ever-increasing rate. Galaxies at the edge of our observable sphere are being carried away faster than light itself can travel, crossing event horizons beyond which their information can never reach us. This cosmic acceleration makes our current epoch incredibly special. We live during a golden age of cosmological discovery, when the universe reveals its secrets most clearly. Future astronomers will inherit a progressively lonelier cosmos as more galaxies slip beyond their observational reach, taking with them irreplaceable evidence of cosmic history and evolution. 100 billion years from now, if conscious observers still exist, they'll see only our local cluster of galaxies surrounded by seemingly empty space. They'll have no evidence that cosmic expansion exists, no way to discover the Big Bang, no access to the rich tapestry of cosmic evolution that we can observe today. The abundant evidence guiding our current understanding will be permanently erased by the universe's own expansion. This temporal window makes every observation we make today incredibly precious. Every photon we capture from distant galaxies represents information that will eventually be lost forever. Every measurement of cosmic structure documents patterns that future civilizations will never be able to study. We're cosmic archaeologists working during the brief period when the universe's autobiography remains accessible to scientific investigation. But within the boundaries of what we can observe, reality reveals itself as something far stranger and more wonderful than even our most ambitious theories predicted. We've discovered that the visible matter making up stars and planets represents less than 5% of everything that exists. The rest consists of dark matter and dark energy, mysterious components that reveal themselves only through their gravitational effects. Dark matter serves as invisible scaffolding throughout the cosmic web, providing gravitational frameworks around which ordinary matter clusters to form the structures we observe. Without this hidden architecture, galaxies couldn't have formed, stars couldn't have ignited, and the cosmic web itself couldn't exist. We're living within a reality where most of what exists remains invisible to our instruments. Dark energy is even more mysterious, driving the accelerating expansion that will ultimately determine the fate of everything we can observe. This invisible force pushes space apart with precisely the right strength to dominate cosmic evolution, without immediately tearing everything apart. If dark energy were slightly stronger, galaxies could never have formed. If it were slightly weaker, the universe would have collapsed back on itself long ago. The fine-tuning required for our universe to support the complexity we observe raises profound questions about the nature of cosmic reality. Either we live in an extraordinarily improbable universe that happened to develop exactly the right conditions for structure and consciousness to emerge, or we inhabit one possibility among countless others where different combinations of physical parameters create different cosmic outcomes. Recent discoveries continue revealing just how much we still don't understand about cosmic reality. Galaxies that formed earlier than our models predicted. Black holes that grew larger than theories suggested possible. Cosmic structures exhibiting properties that challenge our assumptions about how the universe organizes itself. Each surprise reminds us that despite mapping the observable universe's large-scale structure and measuring its fundamental properties with remarkable precision, we remain cosmic infants trying to understand an ancient and vast reality that has been evolving for eons before we existed and will continue evolving long after we're gone. So here we are, at the end of our journey through the most mind-bending scales imaginable. We've traveled from your backyard to the very edge of everything we can possibly observe, discovering that the observable universe stretches 93 billion light-years across and contains more galaxies than there are grains of sand on every beach that has ever existed. We've learned that you are literally made of ancient starlight, that consciousness might be the universe's way of understanding itself, and that everything you've ever seen represents less than 1/10,000,000th of what actually exists out there. The observable universe isn't just incomprehensibly vast, it's a living testament to the extraordinary fact that in this cosmic immensity, matter somehow learned to contemplate its own existence. You are both infinitesimally small and infinitely significant, a temporary arrangement of stellar debris that has achieved the remarkable capacity to grasp infinity itself. Tonight, rest knowing that you carry within yourself the entire history of cosmic evolution, and that your sense of wonder represents the universe marveling at its own magnificent mice. Terry, its own magnificent mice. Terry.